Hello everybody, and welcome to the first video of the course. This video covers an introduction to programming, variables, basic arithmetic with those variables, and a first basic program. So this video has 5 goals. The first is to define what a program is. That seems like a natural starting point for a programming course. And then I'll just show you some basic things you can do in a program, like the print command is a command that tells the computer to output things to you. I'll introduce variables and their values and some basic arithmetic you can do with them. And then finally, we will write a basic program or two at the end of the video. Okay, so first, what is a program? Well, simply put, a program is a sequence of instructions that you give to a computer that specifies how to perform a certain task, or maybe a bunch of tasks, if you have more than one thing you want the computer to do. So informally, a program is actually a teaching task. You are teaching a computer to do something that you want it to do. And that task could be anything, really. Usually it's something to save you time. So computers are more powerful than we are computationally. So typically you would write a program that saves you time doing something by hand. But anyway, the task could be something like, given a side length, calculate the area of a square. Given a radius, calculate the volume of a sphere. Maybe you want the computer to play chess with you or some game with you. So you would need to teach the computer the rules of chess and how gameplay works. Anything like that requires you to hand the computer a list or sequence of instructions that teaches it what you want it to do. So all of that to say, a program, the task of writing a program is teaching. You have to teach this computer, which is both very powerful but also very stupid, what you want it to do. So you have to give it a literal sequence of instructions. The first thing you could teach a computer to do is to print things for you, where by print I don't mean send it to a printer, I just mean have the computer display things for you. So if you write a program that calculates the area of a square, say, you could teach the computer to output or display the area of that square when it's done. So let me just show you how this works in the code. So the first thing I need to do to write code is open Anaconda. So I'm on a Mac, so I can just search for it like this. If you're on a PC, it should just show up in the application list. So Anaconda is the environment we'll be using to write Python code throughout the course. The nice thing about Anaconda is that it works across platforms. So whether you're on a Mac or a PC, it works the same. So when you open Anaconda, you should see this, regardless of what computer you're on. And I guess I should say Anaconda is very powerful. It does lots of things. We don't need it for very much. We only need it to write Python code. So the only one of these applications we will use is Spider. So just launch Spider. And it takes that a second to load. So once Spider has opened, you should see something like this. Notice that there are basically two windows here. There's this window over here that says Spider Editor, temporary script file. There's this window over here. This left window, where the cursor is, that is where you will write code. So this is where you tell the computer what you want it to do. Once you have finished writing your code, you can click play, and the file will run, as it says here, run file. And then whatever the output of the program is will appear over here. So this left-hand side is where you build the code. This right-hand side is where you see the results of the code after you run it. So let me just show you how that print command works. So you do print and then parentheses, and then if you want it to output English to you, like the word hello, you would just put that word hello in parentheses like that, or in quotes. So I've written a program now. This actually is a program. It's not a particularly interesting program. It tells the computer to do one and only one thing, to tell me hello. So if I click play, it has told me over here in the output window, hello, which is nice. Okay, so you can ignore all this, by the way. This is just saying it ran this file, like this temporary.python file. where this code lives. It's just telling me it ran that file and it's telling me where it is on my computer, whatever. It doesn't matter. This is the output of the code itself, of the program. So you can write a program where you make the computer tell you whatever you want. Typically, a first program is to have the computer say hello world, the idea being that the computer has now come online and is now opening its eyes and taking in its surroundings for the first time. So notice over here it says hello world. Notice also, by the way, this output window breaks the outputs down by which run I'm on. So in the first run of the code, it said hello to me. But then I changed the code so that in the second run, run 2, it says hello world. Anyway, so this output window, it keeps track of what it told you previously. So anyway, you can have the computer tell you whatever you want. So if you're feeling sort of lonely and down, you can have the computer express love to you. And there it goes, right? I love you. Maybe you can even tack on, and you matter, so chin up there, champ, or whatever, right? So you can make the computer say whatever you want. That's how the print command works. So let me go back to the slides. So the print syntax is as follows. Print stuff you want the computer to display. If you want it to just be plain English, you actually do have to use those quotations. If you don't use those, it's not clear what the computer will do, but it won't like it. So it gets mad at you. So here's what the computer does when it doesn't understand what you said. If you want it to print plain English, it's expecting quotation marks there. It doesn't know what this is if there aren't quotations there. Notice there's a little red X over there. Red means the computer is angry with you, and then it just won't even output anything now. It says invalid syntax, which is the computer furrowing its brows at you. It doesn't know what you wanted there. So anyway, if you just want plain English said to you like that, is what you would need. There are instances in which you don't need quotes. We'll get to those in a second. Okay, next big topic are variables. So a variable in programming is something used to store information that will be of use in your program. So informally, a variable is a container in your computer's memory. So it's actually a physical place on your computer. You can put whatever you want to inside that container. So variables have a name, so that you can call that container by name, and a value, which is the thing you place inside that container. Okay, so the variable itself is like this box inside your computer's memory. The value of the variable is information you decide to place in that box for storage. Okay, so that's all kind of abstract, I guess. What does that mean in practice? Let me take this out. So I'm going to write a command here that maybe would be of use in a geometry program. So the number pi is approximately 3.14159.265, whatever, right? Okay, so here's a command I'm telling the computer. Pi is this, okay? So when I write a command like that, two things happen. In memory, so somewhere on my computer, there's now a little box, a little container, and that box is called pi, P-I. So if I want to reference that box, I use the name pi. That's the name of the box. Inside of that box, I have placed this number. Okay, so there's a box with a name, pi. Inside of that box is this value. And now I could ask the computer to print pi for me, no quotation marks, and it prints the value of pi. Okay, 3.14, whatever. Okay, so all that to say pi is a variable whose value is 3.1415, whatever this number I gave it. And by the way, if you put quotes around this, right, it's not going to print the variable pi, it will print the English pi, like that, Pi, because you told it to treat it like a piece of English. Without quotes, you're saying, hey, there's this variable, this place in memory called pi, please print the value for me. And there's no restriction on names or values you can give these things. So you can call a variable number and give it the value 18. And then you can print number if you want to. You can then print pi if you want to, whatever. And now if I hit run, it will print both number and pi. Notice one after the other, separated by a new line. So that's the idea of a variable. It has a name and a value that you place inside this box. So before I leave this example, I should point out that the computer reads like we do. It reads from top to bottom. So the computer like starts up here at line 7. This is where the program really starts. This is all just like introductory garbage the computer doesn't care about. So the first thing the computer will do as it reads down is create a box in memory called pi and put the number 3.14 in there. The next thing it does is it creates a box called number equals, and it puts 18 in that box. Then the next thing it does is it prints number. Then the next thing it does is it prints pi. So it just reads sequentially from top to bottom. And notice there can be some issues if you do these things out of order. Like if I tell it first, hey, print number. Oh, and then pi is this. Oh, and then number is this, etc. Well, right now you see it's cautioning me, right? If the computer is reading from top to bottom, it doesn't know what number is right now, right? I mean, you haven't told it to create something called number. It's confused. So it makes sense to have this print command after you've created number. Right now it's not cautioning me anymore. It's like, oh, okay, I know what number is because you named it right here and gave it a value right there, so I can print that. Okay, so that's the idea of a variable. You create storage information for later, for things you need. Okay, well, if you're dealing with numbers, there are lots of things you can do with numbers, like add them, subtract them, multiply them, divide them, take powers, etc. And those all work the way you think they should. So plus is an addition symbol, minus is subtraction, star is multiplication, slash for division. And this is kind of confusing. Star star is what you think the caret would be. So when you want to take a power, you got to do star star. You can't do the caret symbol, which is what you're used to for a power. Okay, so let me show you how that works. Where is this? Okay, so let me put pi aside for a second. So I have number is 18. Let me call that number 1. And my second number I'll introduce is, say, 5, whatever. So I can print either of these if I want to, but I could also print, say, number 1 plus number 2. I could have the computer calculate that sum and print it to the screen for me if I want. And it prints, 18 plus 5. I can subtract the two numbers if I want to, and the computer knows, oh, 18 minus 5 is 13. I can multiply them if I want to. I get 90. I can divide them if I want to. 3.6. I could also exponentiate. I could take powers, but you might be tempted to do that. Python doesn't know what that symbol is, unfortunately. Okay, so it sort of freaks out. You need to do this. So star star is exponentiation. So this will be 18 to the 5th. See what that is. It's this big number, almost 2 million. So anyway, if you have two numeric variables with number values, you can do arithmetic with them if you want to, right? You can multiply them, add them, whatever. The only other thing worth pointing out here is, suppose you want to triple pi. So pi is right here, right? So you might write 3 pi, right? So we in English understand that's 3 times pi. There's an understood times right there. But notice the computer freaks out at me. It doesn't know what this means. So you actually have to put a multiplication symbol there. So if you have number times number, like, again, in English, it's understood that there's a multiplication symbol there. But Python is not speaking English, right? Python doesn't understand the subtleties and the understandings of English. You got to be literal with it. And you really are saying 3 times pi. If you tell it to print that, it prints 3 times pi, which is 9.42, whatever. Okay. So anyway, you can do arithmetic with these things. So finally, let me end the video by writing this program. So let's do something very basic. Let's write a program that calculates the area of a circle given the radius of the circle, right? So at some point in your lives, you all learned this formula. If you know the radius of a circle, you can always find the area by doing pi times the radius squared. So let's go back to our program here. So to calculate the area of a circle, I do need pi, so it's there, right? I also need to know a radius, and that could be anything. So maybe I care about radius 2. So I have a circle going with radius 2. If you want to know the area of that circle, you have to do pi times the radius to the power 2. And so again, you might want to do radius squared like this, but that will not work. You need double asterisk. So pi r squared. And you could even have a command up top, right, like this. Area is, or something, right, if you want it to be more friendly in the output. So it says here, right, area is that. So here is a basic program, right? You can input here whatever value of a radius you want, and the computer will tell you the area of the corresponding circle. And you can get as fancy or not with what you have it tell you, right? Area of corresponding circle is, there's a number, right? Units squared, right? You're dealing with area units, so maybe you're talking about square feet or whatever, right? Area of corresponding circle is this number, units squared. Okay, last thing I'll say is notice that Python defaults to printing a new line or starting a new line after a print command. So I say print this, and then Python immediately starts the next thing on the next line. Well, suppose you don't want that. You can tell it to end with either a single space or not. So I can tell it like, hey, this print command, I don't want you to end with a new line, just end with a space. So there's a space in between these two. And now I run it, it says, oh, it's because I don't give it enough room. Yeah, so if I give this output box more room, notice 201.06 whatever is on the same line, but unit squared is still on the next line because I haven't put this corresponding command right there. So if I wanted to try to put everything on the same line, but maybe a space, you know, like there's a space in here, you don't want the number crammed right next to unit squared. If I output it, I make this bigger, right? It just gives me all on one line. Okay, so at the end of this video, you can now write a basic program like this using numeric variables, using some arithmetic, using a print command.